Hello everyone, welcome again to yet another video of CCNA 4. This is lab 26.1.7, which is known as Snort and Firewall rules ILMS2, and this is what we're going to configure. As you can see the topology above. The objectives of this video is to preparing the virtual environment, firewall and IDS logs, terminate and clear Mininet process. So in a secure production network alerts are generated by various types of devices such as security appliances, firewalls, IPS devices, routers, switches, servers and more. The problem is that not all alerts are created equally. For example, alerts generated by a server and alerts generated by a firewall will be different and vary in content and format. So in this lab, to get familiar with firewall rules and signatures, what is required here is CyberOps working station virtual machine, and you can see the memory that you required, 1.1 GB or we can try 2 GB. So what we are going to do first is to launch Oracle Virtual and change the CyberOps workstation for bridged mode. If necessary, select machine settings, network, and attach to. Select bridged capped, or if you're using Wi-Fi with a proxy, you may need a NAT adapter. So let's go to virtual machine, and here we are. So we are going to the machine, then settings, then network, which we have been asked to use NAT, of which I'm already there because I'm using our Wi-Fi proxy. So but we are supposed to use the bridge adapter, and we are going to try NAT network because we are using a proxy net Wi-Fi, but it seems we can't change those network. We already can see this is an adapter in NAT, so we are already using an adapter, so those settings are correct. So we go to the next now it's time to launch the virtual machine. We're going normal to files, then I think we are in the analyst mode, then we create terminal, we go to a new terminal, then we are going to tap the following: sudo dot, then backslash lab files, support files, scripts, config as dhcp.sh command, then we run. The next thing is to enter your password, that is as an analyst, for you to have all the privileges that are granted to an admin. Then we enter, then it's configuring. You see, configure the NIC to request IP info via DHCP, requesting IP information, IP configurations. So we already have a new IP address. Someone will be like, how can we test this connectivity? We can ping www.cisco, yeah, that is the one we are working with, .com, and see. So ping, let's see, let's check that out. So that is what is ping sent. You can see the amount of data that is buys from so static, technology.com. So you can see actually it's pinging, and we receive information from the main. You can actually stop the ping using the Control C, and that is, we have stopped the pinging. We all know the uses of firewalls and IDS logs in an institution, that is intrusion detection systems, and it's actually used to monitor traffic, and that is for partially they are deployed, they are automatic, and they use certain rules to monitor the kind of environment that is being done. The reason why we are online is because we are going to run a real-time IDS log monitoring in a virtual machine. So let's go to the virtual machine. Let me minimize so that you can see. So again, we are going to enter this command, which sudo ./lab.support.files /scripts /hyperops extended top versions, and we are going to enter. Once again, we will ask for your password, which you already, I hope you are already password that we need here. Then you hit run. Then once you hit run, you can actually see adding controls, switches, host, links, starting network configuration host, and starting controllers, starting switches, add routers, post configure switches, and start CLI. Those are the things we wanted to add Mininet. So on the Mininet prompt, we are going to open a shell using xterm known as R1, and when we hit run, we can actually see node 1 on this other side of my screen. So from this shell R1, we are going to start a Linux based shell RDA. So I've provided the following commands, which is /lab.support.files.scripts. It's almost the same, but except this one we have Snort sh, and we hit the enter, and you can see running. Then we are running that one. So node R1 is now running, and so we cannot see the prompt. Now we are going to open another called xterm h5, which is actually in caps. Then hit run, and another also known as xterm xterm h5 and xterm h10. Then you hit run. You can see a node h10. You'll note that the node h10 is simulating a server that's running a malware, and we are going to enter some commands, which are the lab.support.file scripts, and we have included mal server state sh, and we hit enter. Then we are going to use the command net start tunepa. Then we hit enter, and those are the results. So we have state listening, listen. So we are those figures. So just to expound on what's happening, you've seen our server, this lightweight, is listening into TCP, which is 6666, and we are going to have another to go back to another analyst workstation. Hence we need to start another terminal in our known as R1 also. This is actually a new terminal, but we are going to name it R1. So no absolute path found for shell R1. Alright. You should actually go to the CyberOps that is running virtual machine and end this one, xterm R1. Then it will take you a new node known as R1, so that you can continue giving further commands. So we enter these commands: tail, var, log, snort, alert. Then we enter. Those are more commands. Since no records have been made, it should be empty that way. So we go to the next, and from node 5 the command should be whget 209.165.202.133 : 666 / w32.nimda.amm.exe. Then we hit enter, and that is what we get, the request and that one, yeah, and the connections to that server. So we can see that the connection was successful, there was a response, and there was a save here, and the data was 9.87. So after we ran commands, we had seen that R1 there was nothing, and here you can see now on 3rd of on 6th of March, that is time, which is 12:10 in my area here. So the malicious server hit, was priority, and this one. So you can actually see what's happening. It was captured since we had pre-configured how the malicious data looks like. So we are going to capture next on node H5 the malicious data. So this command tcp dump dash I h dash eth, or this is capital O dash w nimda means to download pickup. This will help us to capture another malware. Then we download the malware, then we hit run. When you hit run, you can see no such device exists. You can see it's now time to terminate. Then we go to terminal, then we press Control Z to move from this Mininet, then we get this stopped. Then we enter the command sudo mn.c. Then it will ask us for a password. It is the analyst password, and you will enter, and this is the results, and you can see in the end clean up complete. So we are completely do away with what you are doing. And thank you for watching. Till the next time, goodbye.